Alright, welcome to today's class, and in this series we'll be checking fractional calculus. My name is Sunday Oluwafemi, and I'll be your instructor for this course. Alright, sit back and enjoy the beauty of fractional calculus. So before we actually go deep into this particular course, I would just love to give a background of this course and for you to see how awesome this course is. So first of all, the classical or traditional calculus, that is the normal calculus derivatives you are likely to be familiar with from your secondary school, from your college, in the 2 years institutions. We have whereby we have the y dy over the x. Then the second derivative we have the square y, the x square. The third derivative we have the 3 over the x3. Then we can have the n y over the xn. But if you observe, you see our n are natural integers, that is a number between the range of 1, 2, 3, 4. So that is the cap, etc. It doesn't stop on 4. Dot. Do you see that? Okay, that is the fraction. That is the classical traditional, or that's classical or traditional calculus. For example, if you have y equals to, let me use another ink so that you don't mix it up. For example, if you have y equals to x squared, so if you take the first derivative, dy dx, that will be 2x. If you take the second derivative, the square y over the x squared, that will give us what? I know you know that will be 2. And that's if you find the x3, that 3y over the x3, that is equals to what? 0. But a question that arose back 1695, and that will be the genesis of fractional calculus, and I want you to pay attention to this. So back in 1695, I get 1695. In 1695, we have the first appearance of this fractional calculus in a letter written by L'Hospital. Right, the letter is by Leibniz, and these are the fathers of calculus, Leibniz. So actually, the question is very simple, but it was very awesome. The question is, if y is equals to x squared as this, and dy dx is equals to 2x, what will now happen if our, now don't forget, the here is 1, here is 2, that is our n. The value of n is 1, 2, and 3. But what will now happen if it's not 1? If it is now half? So what will be the result? So can you give it a try? If y is equals to x squared, and now we know that the y dx equals to 2x, we differentiate to this. But what now happen if our derivative is not a natural number, is now a fraction? It is a fraction. So how do we go about it? Alright, so that is what we'll be checking under this particular course, which is fractional calculus. So we are now advancing from classical traditional course to fractional calculus. So I believe you will find this course very interesting. Alright, to illustrate this better, let me make a graphical explanation of this so that you can have a better insight of what this course entails. Okay, so if y equals to x squared, if you want to plot the graph, we have something like this. You see, this is our x, this is our y, and our origin is 0. Let me extend this a little bit. Alright, this is a quadratic. You have power 2. That means that we have a parabolic, or we have a curve graph. Oh, good. That's y x squared. So by the time we differentiate it, the derivative once, we have 2x, and this is a linear. This is a linear equation, and we have to have a what? A linear graph. Let's just assume we have something like this. Don't forget to be a straight line. This is dy dx. We have 2x. Okay, and the third derivative of this will give us something. By the time we find this, the second derivative, we have 2, and that will be a straight line. I assume that this is 2. So that means I'm going to have a straight line here, and that is the square y over the x squared, which is equals to 2. So the question is now, we have the first instance, we have x squared, and we have this this graph, a curve graph. But by the time we differentiate it once, the graph just goes straight to straight line. So we are not able to find what happened to the system. The system just suddenly moved from a curve straight to straight line. I think there should be a gradual change, whereby we have a curve. The curve is in this form. The curve is expanding little by little. The curve is expanding little by little because it suddenly becomes a straight line. So that's the concern and that is part of the motivations of fractional calculus. You see, when we have the y dx, we have 2x. By the time we differentiate again, we have 2. So how they suddenly change from this position and then it change straight to the straight line? I think there should be a gradual change whereby it's moving, it's changing little by little until it comes to this position. So that is the answer that fractional calculus want to answer. So we want to look closer, we want to take a closer look at a system, how it changes. Not just its change, it suddenly changes by this our classical derivative from parabolic straight to a straight line. So let's check what happens to it. How is it changing gradually until it becomes a straight line? So that is the answer we want to answer with fractional calculus. So with that, let me just give us definitions of a fractional calculus before we continue. So a fractional calculus is a derivative of any arbitrary number, any arbitrary order. It can be real number, a complex. I think this is beautiful. So also it's a branch. Fractional calculus is a branch of mathematics that extends the concept of differentiation. Okay, and integration to non-integers. integers order. So you can see that this will be the various writing course. That is when we have the half, for example, over the x half, or when we have the iota, where over the s is the complex. How do you find the derivative? Or when we have something like this, we have the pi, where over the s pi. So these are non-integers order, and that is what fractional calculus is going to answer. Alright, sit back and enjoy this beautiful course. My name is Sunday. Thank you for watching. See you in the next class.